All right, cool. So let's open that in Excel. So it's not as big of a deal as the standard deviation, but the mean and the median will also, Excel will also do those. So let me zoom in a bit. All right, so click anywhere you want to. If I want to find the mean, well, the Excel command for it is average. I wish it was mean, but it's not. So average, and then just select all, whoops, no. Select all the data. It's a little easier than adding them all up and dividing by 48, isn't it? So, and while we're at it, let me go ahead and do the median. Guess what the command for median is? Median. So 30 and that. Let's see. So the mean is that, rounded to one decimal place would be 0.4. The median was 30. So find the required for an airplane to taxi out for takeoff. Find the mean and median. How helpful is it to find the mean? It's important for determining the quality of flight. It's important for the condition of the runway. It's important for. So which of those sound good to you? C? I think C sounds good too. We didn't really talk about this. Okay. Sure, let's go and do one more because this one's actually quite a bit different. In terms of mean and median, in real life, which one tends to be more important? Do you have a guess? What is that? Mean. People we'll do a lot of stuff with mean in this class because it's easier to work with, but the median is actually a better number for a lot of reasons. The thing about mean, since you're averaging everybody in, if there's one person that's just way out of whack, that one person can move the mean by quite a bit. Like if you say, okay, let's talk about net worth of Americans or something. Well, I don't know what he's worth now, but at one point Bill Gates was worth up around 100 billion. You divide 100 billion by 300 million people. I mean, that one person is raising the national net worth of by like $300 or something, which, I mean, it's not a ton, but the fact that one person can make that much of a difference kind of throws things off. So, yeah, really the median is kind of the better measure, which a lot of, if you look at all your standardized testing, they don't tell you, oh, you scored this number. They say, oh, you scored in the 87th percentile or whatever. It doesn't really matter what you scored. It depends on where you lie among all the people who took the test. So, but we'll pretty well work with mean in this class, at least for the first 2/3 of it, because it's a whole lot easier to work with mean than it is with median. Okay. The only thing tricky about mean is what happens if you have a range like that. So let's actually work through this one right quick. It's not very hard. It's just, okay, I am recording. That's what I wanted to check. Okay, so enable editing. All right. So, well, what do you do if you've got a range like that? It's really, make it bigger. You just pretend like everything's in the middle of the class. Oh, where'd it go? What happened? Oh, that one had just decided not to move. Okay. I was like, it disappeared. Oh, come on, zoom back out. Okay. So if you've got a group data like that, you just say, okay, well, let's pretend like every number in that first one is actually equal to 42 and so forth. Every number in the second one's actually 47, right? So let's do this again. So we got 42 comes up once, 47 comes up 5 times, 52 comes up 9 times, 57 comes up 6 times, and 62 comes up 2 times. All right. So we talked about this last time. How do you find a weighted mean? So, and I could just type 42 and then type 47 5 times and 52 9 times and then do average. But if I don't want to type it out like that, how do you find a weighted mean? So that's the mode, is the most. When you're doing a weighted mean, so a regular mean is just add up the numbers, divide by how many there are, right? For a weighted mean, you add up the number times the weight, and then you just divide by the weights, right? So like these are the actual values we're trying to average is this first column. And then the second column is the weights, right? And we said before that a weighted mean, you do add up the value times weights, and then you divide that by add up just the weights. All right. So let me move that up a little bit. So I kind of want to put something else right there. All right. So if I want to find the weighted mean, well, the first thing I need to do, I need to multiply all the values times their weight. So let me do that. So I want to go value times weight. Well, again, I mean, Excel is great for doing something one time and then just copying it. So to do value times weight, I go value times weight, right? And that one I had to do, but once I do one of them, I can just grab the little box, pull it down, and it'll do the rest of it. Right? Okay, so there's my value times the weights. I need to add them up. I'm going to put sum of the value times the weights. Okay, I don't know what that was. All right, so that's the numerator part. That's adding up all the value times the weights. And then same thing, I need to add up just the weights. So sum of just the weights. And that's it. So just divide those two guys. So 1, 2, 1, 1 divided by 23. Have y'all started kind of using Excel yet? I mean, y'all getting a little bit more. It takes a little bit of a getting used to, but once you get used to it, it's a whole lot easier and a whole lot faster than a calculator is. Oops. So that would be 0.7. And then the actual mean, well, I mean, we kind of had to guess because we didn't have the exact data. So we just said, okay, in every group, we're just going to go with the middle number and say they're all that. So in real life, it was a little smaller. So, I mean, that's community mean is not close. Community mean is close. Means, yeah. So the community mean is pretty close to the actual mean. The difference is less than 5%. Because 5% of 50 is like 2 point something. So we're definitely less than 2 point whatever away. All right. Let's